All right, Mr. Ahmed here for 5.4. Goal for today is to solve systems of equations, and these ones are going to be just a couple special cases that we haven't come across yet. So the first thing we want to discuss is the possibilities for systems of equations, and we are just going to use two linears, and there is one thing that can occur between two lines. They could intersect, okay? So I have these two intersecting at the point 2, 3. So I'm going to go over 2, up 1, 2, 3. So there's my intersection point. I could have a line coming through here in red. And then my other line would also go through that point. Something like that in orange. So this intersection is the one solution. Okay, there's only one way that both of these are going to be true if they intersect. When I'm solving these, I'm going to end up with some values such as x equals 2 and y equals 3. I can actually solve it, no funny business. Parallel lines. Lines can also be parallel. So if two lines are parallel, there's all the solutions for the orange one. And here's all of these solutions for the red one. If these two lines are parallel, that means they are never going to intersect. There's never going to be a solution to this system of equations. It's not possible. They will never touch, so they are both never going to be true at the same time, so the number of solutions is none. An example is when I'm solving this, I might end up with something like 3 equals 30. That is not true. Can't happen. And if I come across something that isn't true, that means there are no solutions to the system. And then there's also the possibility where we have the same line. If we have the same line for both equations, what's probably happening is they're written in different manners, and they go right on top of each other all the way. So that means there's infinite solutions. All real numbers are going to work. When I'm solving, I will end up with something like 7 equals 7, something that's true. -6 equals -6. 0 equals 0. If I end up with something like that while I'm solving, that means that it is the same line and there are infinitely many solutions. So when I take a look at these few graphs down here, we're just going to state how many solutions it has by looks. So when I take a look at this one, these appear to be parallel lines. So to me, that would be infinitely many. So all reals, infinite solutions, all reals. Okay, all real numbers. Again, these two look parallel as well, so that would be an infinite solutions, or all real numbers. And here, we have the same line drawn on top of each other, so that's infinite. Oh, sorry. What am I doing? Oh, I screwed up both of these. I got to backtrack. So here we have the same line, that's infinite solutions, all reals. So as we can see, everyone makes mistakes. Here I said that these were infinite solutions. That is not the case. These lines never intersect. I don't know what I was doing. There is no solution. No solution here because they're never going to touch. I don't know what I was doing. And sadly, I did it twice in a row. Again, these two lines look to be parallel. They're never going to intersect, so that's no solution. They are parallel. So I made an error on that the first time around. So hopefully you watched the whole video and don't just cheat off that. But my bad, I don't know what I was doing. I'd prefer not to start over, so I just scratched these off. Okay, so the parallel lines, they do not intersect, no solution. The same line, infinite solutions, all real numbers. Okay? All right, now we're gonna look at some equations. So when we're solving, we get to choose the appropriate method. For this one, I kind of see y is isolated. I'm going to use substitution. So I am going to substitute what y is equal to into the other equation for y, -3x plus 3 parentheses. In for y goes x plus 3 equals 4. Now we are going to solve this out. Got to distribute. -3x plus 3x plus 9 equals 4. -3x plus 3x cancels, and I get 9 equals 4. So that's one of those cases. Is that true? Is 9 equal to 4? No, it is not. So this would be no solution. No solution. These two lines are parallel. Okay, 9 equals 4 is not true. So I drew a line through my equal sign. That's not true. Okay, our next example. I think I see them lined up. I'm going to use elimination. So I'm going to get the x's to cancel. For me to get the x's to cancel, I need a 10 and a negative 10 because 2 times 5 is 10. So I'll multiply the top equation by 5. And the bottom equation will multiply by 2. So I'll rewrite. Top one, 10x plus 40y equals 30. Bottom one, negative 10x minus 40y equals negative 30. Now when I add the two together, x's cancel, y's cancel, that's 0. There's still a 0 over there. And 30 plus negative 30 is also 0. So 0 is always equal to 0. That is always true. So this is infinite solutions. All real numbers. Okay, so infinitely many, all real numbers. So how do we decide this? Well, if it was no solution or infinite solution, well, I looked at the end. Did I get something that was true or false? If true, infinite. If false, no solution. And substitution, elimination, that's kind of up to you. I decide I'm going to use substitution if variable is isolated. And I use elimination if equations are lined up. All right, that's it for today. Have a good one.